Now, we will go on by explaining the case. Now, this is case number 1. Case number 1 focuses on the following. What happens on case number 1? We have square root of a squared minus x squared. Now, like I said, we base all of these cases on triangles. So we're going to first draw a triangle. It's going to be a right angle. It's going to have a theta. Now, we know here from this that a is going to be the hypotenuse because it's going to be bigger, okay? A is going to be the hypotenuse. Now, if we know that a is the hypotenuse, we must know what the rules are. Now, taking the cases aside, we're going to go and talk about the rules, okay? Now, rule we have are 2, okay? Number 1 says make it so you can evaluate, okay? Make it so that you can evaluate it in a triangle. Okay, I'm gonna slide this down, and then number 2 is gonna be put sides in a relationship. Put sides in a relationship such that we get a x over a for tangent, okay, sine, and lastly secant, okay. Now that we have this, I promised you that this part x over a will be explained right now. Now here is where we have a. We have a here, and finally we got to know whether x will be here or x will be here, and the other part will be a squared minus x squared will be here, or whether it's going to be a squared plus x squared over here. How do we know that? Now, the definition, the rule here says that we got to use tangent, sine, or secant. Why? Because it's more simpler that way. Now, if a has to be at the bottom, okay, if a has to be at the bottom like this rule says, x has to be at the top. Now, if a is equal to the hypotenuse, we got to know, okay, which one of these three can we use in order for the hypotenuse can be at the bottom. Now, we know that tangent is opposite, tan is equal to opposite over adjacent. So adjacent is this. It's not hypotenuse. What about sine? Sine is equal to opposite over hypotenuse, and here is where we have a hypotenuse. So we're going to be like, okay, sine of theta is going to equal hypotenuse with this, which is a, and opposite, this part has to be x. So we're going to erase this, and we're going to say, okay, opposite is going to be x, and this is where we get this. Sine theta is equal to x over a, and this is when this gets accomplished. This means that a is going to be here, x is going to be here, and at the bottom it's going to be square root of a squared plus x squared. Now this is the triangle that represents the case 1. Okay? Now what did we do? First of all, we saw this, we drew a triangle, we knew that a had to be the hypotenuse, and basing on this and the rule of tangent, sine, and secant, we said, okay, we got to use sine because a is the hypotenuse. Judging on that, x has to be at the top, which is opposite. So opposite had to be x. And judging on this, we got the 3 sides of the triangle. Okay?